Hello everyone, welcome back to our channel Only Physics JEE. So today we are going to discuss JEE Advanced PYQ, JEE Advanced PYQ from the chapter Electrostatics. So topic will be covering electric field, flux, we'll be using Gauss law and some applications of Gauss law, right? Application of Gauss law. So there will be a total of 42 questions from this topic, but we will only be discussing 20 to 24 as time permits. So let's start. Okay, perfect. So this is going to be our first question. Okay, so here, let me zoom in a bit. Okay, right. So here we have given charges Q, 2Q, and 4Q are uniformly distributed in three dielectric solar sphere. Dielectric means you can consider it as insulated, okay? So non-conducting. Of radius r by 2, r and 2r respectively as shown in figure. Perfect. With the magnitude of electric field at point P at a distance r from the center of the sphere. So in all the three cases, we are taking point P where we will be considering electric field at a distance r from the center in all the three cases, okay? Then, perfect. So it's a very easy question, right? So let's have a look for sphere 1. So this is our point P. This is R, right? This is our center O. Okay. Now, we know the electric field at any point outside the sphere is kq by r, right? Now the charge given on this sphere was q, so kq by r. Perfect. For the sphere 2, it will be as same. So I should write EP1. So this we have given 2q charge and we are considering this sphere of radius r and at this point on the surface. So electric field at P point for the second sphere will be K 2q by r, right? Now for the third sphere, look, for the third sphere, as the charge is given to the volume, right? And we are considering a point inside the sphere. So electric field at P point will be rho, right? R upon 3 epsilon naught. Now what rho will be? It will be the charge given is 4q. So 4q divided by 4 by 3 pi r cube volume. So what will be r? R will be 2r. So 2r ka cube, right? Into r divided by 3 epsilon naught. So if we solve this, we'll get it will be 4qr divided by 3 will get cancelled, right? Perfect. So 4 pi 8r cube and epsilon naught, right? Perfect. So we can cancel some things. So here it will be 2. Now look, this 1 upon 4 pi epsilon naught, we can write it as a k. So this r will get cancelled. So it will be r square. So kq divided by 2r square, right? This was for the third case. So clearly we can see this is, if this is E naught, this will be 2 E naught and this will be E naught by 2. So it will be E2 will be greater than E1 and then E3. So C option will be correct, right? So it's an easy question, pretty easy question, basic CBSE level question. Now let's move on to our second question. This is going to be our second question. So here we have given a tiny bowl, a tiny oil drop, sorry, not bowl, having charge Q, okay, is balanced in still air with the vertical electric field of strength is. So if it is balanced, then mg will be acting downward and q into e will be acting upward. So first equation will get mg will be equals to qe. Okay. Next, when the field is switched off, then the drop is observed to fall with the terminal velocity. So we know the terminal velocity, due to which if it is going downward, mg will be acting and it is going with the constant terminal velocity. So force, viscous force will be acting 6 pi eta r v, right? So this v is actually terminal velocity. So this will be balancing. So we can also write as mg will be equal to 6 pi eta r vt. Okay. When the field is switched off, the drop, okay, perfect. Now some things are again q we have to find. So it's an easy question, of course. Uh, but we do not have R, right? We do not have R. We have eta, we have density of the oil, we have electric field, and we have terminal velocity, right? So we do not have R, right? So R we do not have. This we have, this we have. So we can write mass as density into volume. G will be equal to 6 pi eta R V, right? So from second I'm solving it. Now this density we have. Volume, what can we write more for the volume? 4 by 3 pi r cube g is equals to 6 pi eta rv. So r, this will be r square. So from here we can get r, right? What it will be? So r square will be, so we can cancel. This will be 2, this will be 3. So it will be 9 by 2. So 9 by 2. Pi will get cancelled, right? So pi we can cancel. Eta v and divided by rho g. Yes, g and pi we have cancelled it, right? Perfect. So we can get r from here, right? We can get r from here. Now if we have r, then we have this force. So as mg will be equal to viscous force and mg also equal to qe, so we can simply write qe will be equal to 6 pi eta rv. Okay, we have to find q, so q will be 6 pi eta r, we can directly put here as 9 by 2 eta v divided by rho g into v, okay, divided by e. So we have to put all these values here and we can get our answer. So answer will be come out to be 8. Remember to put G 9.8. Okay, if you put 10, you will get approximate answer. So G you must put 9.8. Right? So it's an easy question. It's a very basic question. So why we have done this step to get value of R. Okay, to get value of R. So this was the crucial step here. Okay. Next, let's move on to our third question. So third question will be this. Third question will be this. Okay. So what is given in this question? So we have given a uniform charge thin spherical shell. Okay. Of radius r carries a uniform surface charge density sigma. Perfect. It is made of two hemispherical shell. So situation is like this and held together by, okay, perfect. The situation is like this. This is one hemispherical shell. This is another hemispherical shell. Okay. Now the charge is distributed over the surface. Okay. So what will happen? This sphere will apply a repulsive force. Okay. So we have to, and similarly this also apply repulsive force. Both will be equal because Newton's third law will be valid. Now to help them, we have to apply a external force, right, on both the spheres. So this is what is happening here. Now to solve this question, we have two methods. The method one is simply by using dimensions, right? From the dimensions, you can clearly see the answer will be A. Okay. Now to solve it from other method, the method two, we can consider the situation like we have studied about electrostatic pressure, right? Electrostatic pressure. So that's a pretty rough way to solve this question. So we have studied about the pressure or energy per unit of volume. It was half epsilon naught E square, right? So E we can take sigma upon 2 epsilon naught or sigma upon epsilon naught. You can take anything and from there you can find the answer. Okay. So this is our second method. So it's an simple question, easy question, nothing to uh, don't overthink on this question. Okay, let's move on to the fourth question. So this is our fourth question. Now we have a disk of radius a by 4. So this is the disk of radius a by 4 having uniformly distributed 6 coulomb. Okay, placed in xy plane with the center minus a by 2 0 comma 0. Okay, perfect. So this is our situation. Let's say this is x, this is y, and this is z. Okay, now this ring or disk, it's a disk, right? Uniformly distributed. Okay, perfect. So it's a disk, not ring. The center is at, this is minus a by 2 and the radius is a by 4, so it will be like this. Okay, so this will be minus a by 4. Okay, now the 6 coulomb charge, it has a total of 6 coulomb charge which is distributed over its area, no issues. A rod of length a carrying a uniform charge 8 coulomb placed on the x-axis from x equal to a by 4 to 5a by 4. So this is our rod. It has a total charge of 8 coulombs. Okay, now the 2 point charges minus 7 coulomb and plus 3 coulomb are placed here and here. Okay, so like this is minus a by 4, this is plus a by 4, right? And this will be minus a by 4. So this is our charge which is minus 7 coulomb here, and another charge minus 3a by 4. So this will be 3a by 4 and this will be minus 3a by 4 and this will be, so here, yes. So this is our 3 coulomb. Now consider a cubical surface formed by 6 surfaces. Perfect. The electric flux through the cubical surface. So surface are like this, a by 2. Now a by 2, this is a by 2 and this is a. So look, the simple flux we have to find, it will be q enclosed upon epsilon naught. So q enclosed is minus 7 coulomb. From the disk, the you see half disk is outside and other half is inside. So we will just write as 3 coulomb plus. For this, look, this is a by 4, right? Because this point is a by 2. So a by 4 length is inside. So which is fourth. So the charge will be 8 by 4 divided by epsilon naught. Simple. So we'll get minus 7 coulomb plus 3 coulomb plus 2 coulomb divided by epsilon naught. It will be 5 minus 7, so minus 2 coulomb by epsilon. So this will be our flux, right? So A option. It's an again a easy question. Next, move on to our fifth question. So these are like one-liner questions, okay? Perfect. So this is a statement question we have. Let me zoom in. Okay. Now consider a neutral conducting sphere. A positive point charge is placed outside the sphere. Perfect. This is a conducting sphere. Okay. Let me write it. Conducting sphere, and a plus positive charge is placed outside. Right. Now the net charge on the sphere. Okay, so net charge on the sphere will be zero, right? It says zero. Okay. So what will happen? We can analyze situation a little bit. This plus q will polarize this sphere, and minus q will come here. Okay, it has a greater density, and the plus will be distributed here. Okay, so the here density will be less, right? So we have studied a lot about this, right? What the electric field due to plus q will be here. Okay, the electric field due to this, let's say this is plus q, this is minus q. So electric field due to this minus q will be here. This is plus q, this is minus q, and electric field due to this will be here. So we have studied that E due to plus q will be equals to E due to plus q plus E due to minus q, right? That is why inside the that is how in the electric field inside a metallic cage will always be zero if there is no charge inside. Okay, so we have studied this also, but this is a extremely easy question. Like the sphere will have a zero charge, right? Simple. Let's move on to a sixth question. Okay, perfect. This is our sixth question. So there are two options missing. Okay, so I will write these two options. Just give me a second. Yeah, so C option is non-zero, non-uniform, non-uniform, and D option is zero, only at its center. Let's study this question. A spherical portion has been removed from a solid sphere having a charge distributed uniformly in its volume. The electric field inside the empty. Okay, so we can drive it. It's a very simple. Let's say we have a cavity here. This is our center, and this is the center of the cavity. Okay, let's say this has a radius r, and this cavity has a radius r dash. Okay, now this point is O, this point is O dash. Now it is saying the electric field inside the empty space. We don't know where, anywhere it could be. So let's say it is here, P point. Now this distance, this is, let's say, r vector, and this distance, let's say, r dash vector. Okay, can you see? Let me zoom in. Yes. So this is our r vector, r dash vector, and let's say this is our we just call it o dash vector, right? So we can write o dash plus r dash, o dash vector plus r dash vector will be equals to r vector. Okay, so o dash will be r vector minus r dash vector. Are you getting me? Perfect. Now let's find the electric field at this P point. Now, sorry, we can use the negative charge concept here. Okay, so let's say if there was no cavity, so electric field at P point will be what? Rho r upon 3 epsilon naught. Yes. Now, if let's suppose this only sphere was present and at point P, so this is due to a big sphere, right? And this is electric field at P point due to small cavity. So I just write due to cavity was rho. The density will be same, right? R dash divided by 3 epsilon naught. Now, as this cavity is removed, so from this big we need to remove this. So net P will be electric field at point P will be EP due to big sphere minus electric field P due to cavity. Okay, the sphere which was present in the cavity. So what it will be rho r vector divided by 3 epsilon naught minus rho r dash vector divided by 3 epsilon. So it will be rho by 3 epsilon naught r vector minus r dash vector, and r minus r dash vector we have already calculated, rho upon 3 epsilon naught o dash. Okay, yes. So what we get that we can take any point inside the cavity, it will be always in the direction of o dash. Okay, so if the direction is constant, value is also constant, so we can say electric field inside everywhere will be uniform, non-zero, and uniform. This option is correct. Zero wrong, non-uniform wrong, it will be uniform, and zero only at its center, no. At every point it will be rho o dash divided by 3 epsilon, which is constant, right? Which is constant. Even both direction and magnitude is constant here. Okay. So this is a easy question again. We have studied these negative charge concept, right? So if there is a cavity, we subtract the electric field and so on, so forth, right? Perfect. Many like this concept is used like in the so many chapters, right? We have used this uh, negative object concept in the moment of inertia also, right? So it's a wide range, like it has a wide range of applications. Okay, now let's move on to our seventh question. Seventh question. So we have this. Okay, so in this question, three infinite long charge sheets. So they are sheets. Okay, remember a concept. It's just given sheet, so we have to consider it as a non-conducting. Okay, at like if there is a line, sphere, okay, anything. If there is nothing is given there about conducting or non-conducting, you always consider as non-conducting. So for conducting, the question must mention that it is a conducting. Okay, so we have non-conducting sheets. So this is first, this is our second, and they are infinitely long. So they are infinitely long. Okay, and this is our third sheet. Right. Now here is our point P. This has this charge density sigma. This has minus 2 sigma, and this has minus sigma. Now electric field at P, this is a very easy. Due to this, it will be here E1. Let's say this is first sheet, this is second, this is third. Due to second, electric field will be in this direction because it will attract, and due to minus sigma, it will be again in this direction. So we just have to find electric field at P and we just add them E1, E2 and plus E3. So due to E1 it will be sigma upon 2 epsilon naught, plus due to E2 it will be 2 sigma upon 2 epsilon naught, plus due to this it will be simple sigma upon 2 epsilon. Yes, due to non-conducting it was divided by 2, right? Due to conducting it was sigma upon epsilon. So we have to consider it as non-conducting. So we will get sigma upon 2 epsilon naught. This will be sigma upon epsilon naught plus sigma upon epsilon naught. We'll get 2 sigma upon epsilon naught, and the direction is downwards. right? So direction is downward. We can write it as EP vector will be 2 sigma upon epsilon naught minus 2 z cap or k cap, right? So we will have C. Okay. So again, extremely easy question. Nothing to worry here. Let's move on to our eighth question. Okay, perfect. So in this question, there are six charges equal magnitude, three positive and three negative, are to be placed here. So we have a hexagon, a regular hexagon it is, yes. So hexagon versus regular hexagon. Regular hexagon have all the sides equal, okay? Such that field at the center is double that of what it would have been if only one positive charge is placed at R. So if there is only one charge at R, then electric field will be simply what? KQ by A, right? Electric field will be KQ by A square, sorry, KQ by A square, right? Now we need double of that. So we need 2KQ by A square. Okay, we need double that. So what should be the combination? So we can just go through the options one by one. So three positive, three negative. Okay, one is missing here. It must be positive, right? Now we have to put the charge in this way. So this is P, this is Q, this is R, this is S, T, U. Let's start to put first plus, 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 minus, minus, minus. So due to this, let me rub this part. Okay. So due to this, electric field will be here. Due to this, electric field will be here. So 2E simply, right? So this is just E naught. So 2E naught we need. So E at P or no, it's O, right? E at O will be 2E, right? So 2E. So 2 is here. Now similarly 2E will be here, and due to this 2E will be here. So it is no way, right? The resultant will be in this direction because this is 120 degree. So this option is wrong. Let's put B option now. So this is minus. Okay, let me rub all of them. So this is minus, plus, plus, minus, minus, plus. Okay. Now, due to this, electric field will be cancel each other. They will cancel each other. They will cancel each other. So due to Q, it will be 2E. So 2E will be here. Yes, E and E. So 2E. So, but this is wrong because we needed net electric field in the direction of U. So this is also wrong. Let's move on to a third option. Yes, we have to check them, right? It's very easy. So minus, plus, plus, okay, minus, plus, and this is minus. So due to P and S, it will cancel each other. So they will cancel each other. Q and T will also cancel each other. And R due to this E and due to this. Yes, so 2E will get this. So C will be the option. Okay. So D will automatically be wrong. So it's an easy question, right? Very easy question. Let's move on to our ninth question. Ninth question. Okay. Yes. So a Gaussian surface in the figure is shown by dotted line. Perfect. The electric field on the surface will be. Remember this? This is a very interesting question. Yes, it's based on the concept of Gauss law. So Gauss law say that flux due to this surface will be due to charge enclosed divided by epsilon, right? But the electric field is due to all the charges in the uh, you know in the inside as well as outside. So remember this. When you consider electric field, it is due to all the charges, but flux will be only due to, so what we get, the net flux is only due to enclosed. So it comes out automatically. That is the mathematics here. Okay. So electric field on the surface will be due to Q1, Q2 only. Wrong. Due to no. Wrong. So it will be due to all. Okay. So if you try to find out, it will not be zero. Right. So it will be due to all the charges inside as well as outside. But the flux, when you start to calculate the flux through this sphere, the mathematics will say it will come out to be charge enclosed by the surface. So it will be zero. Okay. So remember this. That is a nice concept. Next, move on to our 10th question. So we are doing pretty fast, right? Because these are easy questions, right? Okay. Now, what we have here is a metallic shell. So this is a metallic shell. Q is kept inside its cavity. Which of the following? Okay, perfect. So let's start to study this. Now this is a shell. This we have a shell. Okay. Now Q is placed like here. I mean, it is not at the center. It is just like a little offset from the center, right? Now, look, this is a positive charge, right? Let's consider, so look, the electric field are going outside, so it must be positive. Okay. Now look, due to this positive, the negative charge will start to accumulate here inside the I mean the surface which is inside. Okay. Now if negative is here, then positive will distribute here, right? Positive will distribute here. Now there is a slight difference here, which is what? This negative will be more here and less here. Okay, so let me rub some. Okay, because why? The skew is closer to this surface than this. So negative, the charge density over here is less. Charge density over here will be more. But as soon as this positive, we have studied on a metal, if you give a plus positive charge on a metal, it will uniformly distribute it to the surface. So this positive will be distributed uniformly to the surface. So here we will have uniform distribution. Here we will have uniform distribution, but inside it is non-uniform distribution. Remember this. Inside it will be having non-uniform distribution. Okay, perfect. Now look, so electric field will be like what? Perpendicular to the surface. From here, electric field will be like this. Okay, so it will be perpendicular to the surface, right? So it will be like this, right? But inside this part of the shell, it will be zero, right? Inside the metal, if there is no charge, electric field must be zero, right? And then outside, it will be like a sphere. Simple. So it will be like this. Okay, perpendicular to the surface. It will be like a sphere we have studied, right? So look, directly we can, if we do not even know the concept, we can directly eliminate three options. Why? Look, there is a line here, so this is wrong. Again, there is a line here, wrong. Again, there is a line inside the spherical shell, right, where the material is there. So not wrong, not good. Okay. So this I'm talking about this part, this, and this. So that is why these all three are wrong. Okay. So even if we don't know the concept, simple, by you know by eliminating odd one out, right? So this is the odd one out among the three. Yeah. So this is a basic reasoning question here we have. Perfect. Let's move on to our 11th question. Again, I think yes. So this question is again based on electric field. We have three positive charges equal value are placed at vertices of equilateral triangle. Okay, so here we have one, here we have another, here we have another. Now, so we have to make the resulting field lines. So here we can also like eliminate odd one out. Look, the field here is making circle. So electric field do not make a circle. So this is wrong. This is also wrong. This is also wrong. So like C will be the option, but we can actually understand this. Okay. How? Look, at this point, okay. Now what will happen? At this point, there will be field, but look, okay. So how will study it? Now look, due to this plus Q, electric field will be like this, right? And due to this, electric field will be like this. And due to this, electric field will be like this, right? Now what will happen is at these 2 points, right? Due to these, electric field will be zero at the mid, but electric field due to Q will be here. So it will be like this, and electric field will be like this. But due to Q only here will be like this. From for similarly here will be due to this Q, and at here it will be this. So electric field will like this. Okay, we can just complete the diagram. Now in this figure there is no middle line, but it is fine. We need to make just approximate diagram, right? Electric field from here will go like this. Okay, so the field will be like this. So we have our option. Next, move on to 12th. So these questions are pretty easy, right? Let's see what we have here. Electron of mass me, initially at rest, moves through a certain distance in a uniform electric field. So we have a electron, and in a uniform electric field it is moving. So like we have studied that electron moves in opposite to the moves in the direction opposite to the electric field. And a proton initially at rest, so it is taking a time. So let's say it has moved a distance x and it has taken time t1. Now again we have electric field. This time we have a proton. So we have a proton, and we know proton moves in the direction of electric field. Equal distance in a uniform in this uniform electric field, but it is taking u2 time. So this is x. Okay, but time it is taking. Both will take different time. Why? Look, we have same charge and same electric field, so force will be same. So here force will be EE. But as mass of electron is less, so acceleration of electron will be more. Okay, so mass of proton, acceleration of proton, EE. So we will have acceleration of electron will be EE by ME, and we will have acceleration of proton will be E capital E by MP. So look, ME is less, so AE will be more. So AE will be more. Okay. Now find T2. Okay, so simple. We can use second equation. So x equal to half acceleration E by ME, into T1 square. Similarly for this, it will be half E by MP to T2 square. Okay, so T2 by T1. So let's divide 2 by 1. So 2 divided by 1. So we will get, this is 1 will be equals to T2 square into 1 by MP will be left, and here will be T1 square 1 by ME we have left. So if you cross multiply, MP will come up and ME will go down. Okay, so we have T2 square by T1 square. Simple, it is very simple. You can just simply solve them. MP divided by ME. So we will have T2 by T1 will be MP by ME to the power. So yes, we will have B option. Okay, it's in these are easy question. These are pretty easy question. Let's move on to a 13th question. 13th question. Okay, so this question looks interesting. One or more option. Okay, so options are missing. Let me check. Okay, yes. So I will give the option first. You can read and try to solve yourself. H is greater than, if H is greater than 2R and small r is equals to 4R by 3, then phi will be Q upon 5 epsilon naught. B option is same, but this is 3R by 5. It's 5. So phi will be Q upon 5 epsilon naught. Same option, almost. The C, H is less than 8R by 5. And R is 3R by 5. Flux, it is showing 0. D will be H greater than 5R. Oh no, 2R. And R is greater than R. So flux will be Q upon epsilon. Okay. Capital Q you can take. Okay, perfect. Let's see this question. A charge shell of radius R carries a total charge Q. Okay. So we have a shell, okay, of radius R and it is having a charge Q. So if it is a shell, the charge will be distributed on the surface. Okay. Now we have a closed cylindrical surface of height h and radius small r. So we have like this. This is our cylinder, okay? So it has a small r radius and height h. And we have sphere. This has a radius, okay? Now the center of the cylinder is a point on the axis, which is okay. So this is the center of the sphere. Which of the following is correct? Given the flux through this with this center same as of that shell. Okay, so we have put our sphere like this, right? So in the different situation, we have to make the diagram and we have to study. Now look, if H, if this sphere completely, like this cylinder completely engulf our sphere, so it will be like this, right? Somewhat like this. So R, if R is greater than R and H is greater than 2R, then the whole sphere will be inside this and we will have flux simply Q upon epsilon naught, right? So D option is correct. H is greater than 2R, R is greater than R, and flux will be Q upon epsilon, right? So we do not have to check this. Okay, perfect. Now the next part is what? Next part. Oh, so let's start from the first itself. H is greater than 2R. H is greater than 2R means the upper part is inside but R is 4R by 5. Okay. Uh, so if R is 4R by 5 less than R, so it will be like this. Okay. Mm, Let me make the perfect sphere for you guys. Okay, look, this is not actually a sphere, it's more like circle. Okay, yeah, it's like a circle. But remember, we have this surface here, but it will be from all side, from the whole, like this is our curved surface of the cylinder, right? This is our curved surface, right? Okay. So from all the sides, right, from 360-degree, it will be outside, not just this. So here we are looking at only one surface, and this is only two. So it will be like one or two surface. It will be like whole. Okay, like if you have a bowl and you put straw in it, right, or anything. So from all the sides, this side, these sphere will be out. Okay. Remember this. So look, so this is our 4R by 5, right? Now look, this will be R. So we just need to find the part which is inside the circle, right? If this part we know, if the area we know, right, then we can simply find our answer, right? So look, if I make like this and let me dark this portion. So this part is inside the circle. So if this is R, this is 4R by 5, so it will be 3R, right? So it will be 3R by 5. So this angle will be what? This angle will be tan 3 by 5, so it will be 37 degree. So if this is 37, it will be 53 degree, right? Simple. Okay. Now we can use the concept of solid angle. What was it? Solid angle was 2 pi 1 minus cos phi. So we have cos phi we can put at 53 degree. We'll get 2 pi 1 minus cos 53. So it will be 2 pi 1 minus cos 53 will be 3 by 5. So it will be 4 pi by 5, right? We have this solid angle. From this we can find our area. So area will be simply 4 pi by 5 into r square. But look, we have one surface here, one surface downward. So we have to multiply. So let me write it again. So this is the area of one part. So we will have required area. Required area will be twice of this. So 4 pi r square by 5. It will be 8 pi r square by 5. Okay. Now remember this, which area I'm taking. Okay. So it's a great concept. The area which is inside. Okay. So some will say, sir, let's take the surface area which is outside and then we can subtract it from that. But what will happen is we can only see two surfaces, right? This is not a 3D diagram, this is a 2D diagram. So we are looking at only two surfaces outside. So we will just take like this and we'll multiply by 2. But it will be wrong. Look, this one is on the right side, this is on the left side, one will be on the top side and one will be on the bottom side. So it will be 4 times what you calculate, right? So leave these complication aside. We can just calculate the surface which is inside the cylinder. Okay, so this is the inside the cylinder. Now we can find the flux here. It will be Q enclosed. So Q will be yes, Q enclosed upon epsilon. So Q will be sigma into this area, 8 pi r square by 5 divided by epsilon naught. So sigma was what? Q upon 4 pi r square, right? Into 8 pi r square by 5 epsilon naught. So it will be 2. So 2q by 5 epsilon naught. No, so this is wrong, right? Let's go and solve B part. So this time it will be 3r by 5. So I can simply write, so this was A part, okay? Now for simply B part, it will be 2 pi 1 minus cos. It will be this time 37 degrees. So it will be 2 pi 1 minus cos 30. It will be 4 by 5. So it will be 2 pi by 5, right? Okay. So area of one part will be 2 pi by 5 r square, and required area is twice of that, so it will be 4 pi by 5 r square, right? So from that flux we can calculate, simply it will be q upon 4 pi r square into 4 pi r square by 5 upon epsilon. Simple. Just 8 from like in the place of 8 pi r square by 5, we have to write 4 pi r square by 5. Okay, so 4 pi r square, it will be cancelled. It will be q upon 5 epsilon, which is matching. Yes, so B is correct. Now for the C part, look, h is h is less than 8 r by 5. Okay, and r is 3 r by 5. So r is 3 r by 5. Yes, so is this option right? So h is 8 r by 5. So what will happen is, we have like this. Okay, let me check. Yeah, it is written correct, right? Okay, perfect. So we will have h less than 8 r by 5, and we required more than 2r. Then only the upper two surfaces will be inside. Now if it is 8 r by 5 less than 8 r by 5, right? So how it will be? So our sphere will be like this. Yes. Why? Because look, this is h, right? And if I say it is less than 8 r by 5, let's say it is 8 r by 5. So this part and this part will be left, because this total is what? This total is how much? This total. So this total is how much? This total is 2r. Right? Similarly, this is what? 3r by 5. But this total is how much? It is r. So what will happen? Cylinder will be engulfed by our sphere. So there won't be any charge enclosed by the cylinder. So this option will be correct, because so 5 will be 0, right? So it's a kind of interesting question. So we will consider it moderately. Remember this, the concept of solid angle. Okay, so very important. Next, let's move on to our 14th question. Let's move on to our 14th question. Okay, right. So we have our 14th question. Now, electric dipole is like this, is held fixed at origin O in the presence of uniform electric field of magnitude E naught, okay? The potential is constant on the circle of radius r centered at the origin. So potential is constant on this circle. Okay, so this circle is actually equipotential surface. Let me make the diagram. So we have circle. This is our one line. This is our second axis. This is x. This is y. Okay. Now the dipole moment is like this, right? And we have these two. This is A point and this is P. And both are at 45, 45. So they are at 90 degree. Okay, so and this is our P vector. Thus potential. Now this dipole moment is placed in a uniform electric field E naught. So there is external electric field also, but we do not know the direction of it. In the question it is given the potential is constant on the surface. So this circle is actually equipotential surface. It is actually equipotential surface. And we know at equipotential surface electric field is always perpendicular, right? So electric field is always perpendicular. So let's first find the electric field at A and B, okay? Now look, due to dipole electric field will be in this direction, which will be 2E, right? Remember 2E. So E will be Kp by R cube. So it will be 2 Kp by R cube. And at B it will be opposite direction. So it will be tangential, right? Will be E. Remember? In the axial it will be twice than the equatorial. But in the axial it will always be in the direction of dipole moment. But at the equatorial the electric field will be in the opposite direction of the dipole. Okay, perfect. We have E, but remember we have an external electric field also, E naught. Okay, so look, at A, if this external electric field is at any other angle, then we will have a parallel component which we do not want. So E naught must be in this direction. Okay, right? Either in this or either in this. Perfect. So from A, we cannot get our answer. Let's go to B. So look, electric field will be in this direction, right? And this is a 90 degree. So when it is parallel to it, so it will also be parallel to this. So either E naught will be in this direction or either it will be in this direction. Look, if E naught is in this direction, the E and E will add up and we will have a electric field which is parallel to the surface, not perpendicular. So this is not correct. So at point B, their electric field must be zero. So how it will be zero? It will be zero when E will be equal to E naught. So we got our direction. So E naught will be in this direction. So this is wrong. So it will be in this direction. So simply from B, from point B, E must be equal to E naught. Okay. So E was Kp by R cube will be equals to E naught. This is our first, and at A simply it will be 3E, so we can calculate that, right? Okay, perfect. Let's go to check our options. The magnitude of total electric field on any 2 points on the circle will be same. Wrong, it will be different. The total electric field at point A will be this. No, it will be 3 times, right? So it will be, this is the wrong point. R we have to find. So from here we can find R, right? So K we can write 1 upon 4 pi epsilon naught P by R cube is equals to E naught, right? So let's exchange them. We will have 1 upon 4 pi epsilon naught E naught and P to the power 1 by 3 R. So yes, this is correct. C is correct. Total electric field at point B will be 0. Yes, 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 yes. This is also correct. So we will have C and D as our answer, right? So it's right. So it's a again moderate question, very interesting question. Okay. So electric field at A and B will not be same. Okay. Let's move on to our next 15th question. 15th question. Okay, perfect. Oh, it looks dangerous, no? Let's see if it is dangerous. An infinitely long, thin, non-conducting wire is parallel to z-axis. Okay, so this is carrying a lambda as a charge density. It pierces a thin, non-conducting shell of radius r in such a way that arc PQ subtends an angle 120 degree. Okay, perfect. Right. Permitted. Which is the following? Electric flux we have to find and electric field we have to study. Okay. Hmm. So this is our non-conducting spherical shell. So if it is a non-conducting shell, there won't be any polarization. Okay. Right. Now look, this is the part which is inside. Okay. This is radius r. This is 120 degrees. So we can consider it as 60 and this is 30. So this length will be r cos 30. So length inside will be 2r cos 30 degree, right? So 2r cos, this will be r cos 30 and this will be r cos 30 degree. So 2r cos 30, 2r root 3 by 2. So we will have length r root 3. This length is inside the sphere. Okay, perfect. So flux we can directly calculate. It will be charge inside. So charge will be lambda into r root 3 divided by epsilon naught. Simple. So it will be root 3 r lambda upon epsilon naught. So A option is correct. Now the Z component of electric field is 0 at all the points on the surface of the shell. Let's check this first point later. Electric flux to the shell. So this is wrong. C is wrong because A is correct. The electric field is normal to the surface of the cell at all points. Yes, so this is correct. Now look, this surface is non-conducting, so there won't be any polarization. So it is like if you consider it exists or not does not exist, you can choose anyone, right? So we have simply a wire of infinite length, and we know electric field is perpendicular to it, and it was at any distance r, it was 2k lambda by r, right? So it will always be perpendicular. If there was polarization, then the situation would have been different because here there will be positive charge and inside there will be negative charge, and then we have to consider the situation. It will become a little bit complicated. Okay, but as it is a non-conducting, as the sphere is non-conducting, so there won't be any polarization, and due to this, if you consider this sphere, it exists or it does not exist, it is your choice. Electric field won't be changing, so it will be perpendicular to this line charge. So this D option is correct and B is wrong. Okay, so we will have the options A and D is correct. So A and wait, it will be B is correct. The Z component of electric field at 0 at all the point on the surface of the shell. Yes, so this is correct. B is correct. The electric field is normal to the surface of the shell at all Wait. Okay, I have uh, read these 2 points a bit incorrectly. The concept is right. Wait, I have to read them again. So Z component of electric field in is zero at all the points of the shell. Okay, so this is shell. Now electric field will be here, 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 right? This is our line charge. So electric field will be here, 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 here. So there will be no Z component. Z component is zero. So B is correct. Okay, C is wrong. Electric field is normal to the surface of the shell at all points. No. At this point, it is parallel. At this point, it is at some angle. At this point, it is normal. At this point, it is normal, but it will be at different angle. Okay, so this point is wrong. Okay, I have studied this point a bit wrong. So A and B will be correct. Okay, again, I'm telling you, A option we got from the calculation. Now, as this sphere is non-conducting, so there won't be any polarization, due to which due to which this sphere will not change the electric field due to line charge. Okay, so it will not change, hence electric field will be perpendicular to the line charge as we have studied. Now if you make the sphere, at this point it looks like it is parallel to the sphere. It At this point it is at some angle, at this point it is definitely normal, at this point it is at again at the angle, and at this point it is parallel. Similarly here it is parallel, angle, at some angle, increasing, this becomes 90, then decreasing, and it becomes 0 degree. So it will look like this. So B option is wrong because yes, there won't be any Z component of electric field. It will be in this direction. It will be X or Y. We don't know. The electric field is normal to the surface of the shell at all points. No, at some point it is normal, but other point it will not be normal. So it is like, yes, we can consider this question as a hard. This is a tough question, but it is a very interesting question to understand the concept. Okay, so let's move on to our 16th question. Let's move on to our 16th question. So here is our 16th question. Okay, so this question is again our cavity one. So you can solve this. I can give you some options. We can check this option, okay, directly. So it will be E uniform, magnitude is independent of A, but direction depends on A vector. D, E is uniform and both magnitude and direction depends on A. So A is this. So like I can directly write the OP is A. Okay, so at any point we know, at any point, let's say this is some A point. So electric field at A, we know rho upon 3 epsilon naught will be OP vector. P is center. P is the center of the cavity. It is given. So OP is A. So rho A vector divided by 3 epsilon. Let's check each and every point. E is uniform. Yes, this is correct. Its magnitude is independent of R2. Magnitude is independent of R2. R2 can be anything. We just need to know this A. A is, but its direction. So the magnitude is independent of R2. Is it? Is it? No, the cavity can be of like uh it can be like this. So situation can be like this. So like cavity can be like this, right? And let's suppose this is our center and this is P point. So A dash will be same. So is independent of R2, this is also correct, but its direction depend on R. No, direction does not depend on R, right? Because at all the points, direction will be here only. Yes, it will be in the direction of A vector. So this is wrong. So this point is wrong. Is uniform, right? Magnitude depends on R2. This is wrong. Again, magnitude is independent of R2. We have just proved. Is uniform, magnitude is independent of A. No, magnitude depends on A. So this is wrong again. Is uniform, both magnitude and depends direction depends on A. This is correct. So D will be the option. Okay, so this is an easy question. We have already studied this situation in the previous question. Okay, so let's move on to a 17th question. So this time the questions are like a bit easy on the easy side, right? Let's go. Okay, perfect. We have a 17th question. The figure below depict two situations in which two infinitely long static line charges. Okay, so these are two different situations. So in one situation, this is lambda, and we have plus q here. This is again lambda, this is again lambda, and we have this time minus q. Parallel to each other, minus q, equilibrium between them. The point charges are confined to move in x. Okay, x only if they have small displacement. So small displacement mean they will be doing SHM. Okay, about their equilibrium, which are correct. So you will say like let's displace it here. It will go like this. Both are same because equal and opposite forces will be acting. No, just check them. Let's displace it here. If we displace it here, due to this we will have a force here, and due to this we will have a force here. So let's say we have displaced it x, so it will be r minus x. Let's say this is r and this is also r, so this distance will be r plus x, right? Now at plus q we will have a force in this direction due to first, so it I write it as for f1, and here it will be f2. So I'm displacing it here. I've displaced it here. Okay, so we'll see f1 will be 2k lambda by 2k lambda by r minus x, right? And f2 will be 2k lambda by r plus x, right? We know f1 will be more, so we will just write f1 minus f2. So 2k lambda 1 by r minus x minus 1 by r plus x. So we will have r plus x minus r minus x upon r square minus x square, and it will be 2k lambda. So r will get cancelled. We will have minus 4k lambda x. No, so plus divided by r square minus x. So we have displaced x in left direction, and force will come out to be plus x. So it will have this. And we know this x is very small, so we can consider it as r square only. So it will be 4k lambda x divided by r square, right? So we have displaced it in here. We got force in this direction. Okay, so this will be doing SHM. Let's see this. Look, we do not have to solve this. When this charge comes here, we have displaced in this direction. Now this will attract this, and this will attract this, but the attraction this F1 will be much more than F2, so it will keep on going in this direction, right? So it will not do SHM. This will do SHM, this will not do SHM. So like the instinctive way to solve the question is absolutely wrong. Just write the formula, solve them, take 1 or 2 seconds, don't make the mistakes. So this will be wrong. So plus q will execute SHM while minus q continues to move in the direction of displacement. So C will be correct. Okay. So I will consider this as a moderate one. Look, remember always solve question. Don't go instinctively and just like, yeah, they are similar and let's solve them. Okay. Never do this. Okay, so let's move on to our 18th question, shall we? Okay, perfect. Okay, so we have E1, E2, and E3 are the electric field at a distance r from a point charge. Okay, so we have a point charge, and at a distance r, electric field will be simply kq by r square. Okay, next we have a line charge, and at a distance r, the electric field will be k lambda by 2k lambda by r, right? It was 2k lambda. Okay, and at infinite plane. So remember again, it is not saying conducting or not. So we just write as non-conducting. It will be sigma upon 2 epsilon naught. Okay, it will be constant. Now, question, if all the three are equal, so they are equal, so we have to put them equal. Uh, Infinite plate of charge, uniform charge density. Okay, so we have to write kq by r square will be equal to 2k lambda by r equal to sigma upon 2 epsilon naught. So this in the question we have given. Now at a distance r naught, okay, then q equal to this. So q and sigma we have to equate. So let's equate these two. So it will be 1 upon 4 pi epsilon naught q upon r square will be equal to sigma upon 2 epsilon naught. So epsilon naught cancel. This will be 2. This cancel. So q will be 2 pi r square sigma. Is it matching? No. So this is wrong. Now r, we have to equate lambda and sigma. So let's equate these two now. So we will have 2k lambda by r equal to sigma upon 2 epsilon. So it will be 4 pi epsilon naught. So 2 and this 2 cancel, epsilon naught cancel. So lambda will be, we need r, right? So let's say r will go here, sigma will go here. So r will be lambda upon pi sigma. Yes, there will be no. So is it matching? No, it's not matching. Okay, now C option. Now we have to put R naught uh, by 2 and in E2 R naught by 2. Okay, so even R naught by 2 will come out to be 1 upon 4 pi epsilon naught Q upon R naught by 2. So R naught square by 4. So it will be like this. And E2 R naught by 2 will be, it will be simply 2k lambda by R naught by 2. So it will be 4k lambda by R naught. Okay. Now we know this is a 4E1 and this is what? This is 2E2. This is 2E2, right? Okay. Yeah, so this was E1 and this was E2 and both were equal. So we will have now 4E1 and this is 2E2. So, i- so this is twice of E2. Yes, this is correct. So this is E1 is 4 E1 is what? Twice of 2E2. Yes, this is correct. Now why I'm saying this, look, we know E1 and E2 are equal, right? So let's say it is dash, it is dash. So for E1, this is 2 E1 I can write because E1 and E2 are equal. So what is that? So E1 dash is equals to twice of E2 dash. Yes, and this option is saying right. C is correct. Okay, let's check this option also. So E2 R naught by 2 we have already calculated is 2E1 And for E3, the effect of R is nothing. So it will be simply, so E3 dash, which is R naught by 2, will be simply E3, right? So this is wrong, okay? Because E2 is twice of E3, so we can write it as E3 is equals to E1, right? E3 was equals to E1. So it is not, it is twice. So this is wrong. So this is wrong. So only C option is okay. So yes, this is a nice question again, but it is very simple, nothing to worry about it. Let's move on to our 19th question, shall we? Okay, perfect. Again, we have two non-conducting solid spheres of radius r and 2r having uniform charge density. So this is one, this is another. Touch each other, so they are touching each other. Okay, so it has sigma 1, sigma 2, its radius is r, and this radius, its radius is 2r. Look, if even if they are touching, because of their non-conducting, charges will remain on them, so they will not get exchanged. Okay, the net electric field at a distance 2r from the center of the smaller sphere. So this is center. So if this is r, then this is r, this is r. Okay, so at this point P1, and look, if it is saying 2r from the center of smaller sphere along the line joining the center of the sphere, so along this, the P2 can also be here, right? So this is r, so this is r. Okay, so these 2 points we have to consider. Okay, this is center O, this is O dash. So P1 and P2 we have both consider. Okay, so electric field is 0. Now electric field due to at P1 due to smaller sphere will be equal to electric field at P1 due to larger sphere. So due to small sphere it will be simply KQ by KQ by uh, 2r square, right? Right? So 2r square, and due to larger sphere it will be sigma 2 r divided by 3 epsilon, right? So let's just equate them. So it will be k 1 by 4 pi epsilon naught q upon 2r 4r square, right? It will be root 2 r upon 3 epsilon naught. Yes. So let me convert them. So if I multiply r, divide by 3 and multiply by 3 and multiply by r, multiply and divide, and 3 divide. So this q upon 4 by 3 pi r cube will be sigma 1. So rho 1, sorry, not sigma, rho 1 r upon will have 3 pi 4 by 3 epsilon naught we will have, and 4 we will also have. Okay, equals to 2 r upon 3 epsilon naught, right? 3 epsilon naught, 3 epsilon naught cancel. We need to find rho 1 and rho 2. R also get cancelled. So rho 1 upon rho 2 will turn out to be 4 for the P1. Now let's consider P2. So EP small will be equal to EP2 large. Okay. Now for the smaller one, it will be same. So it will be same. I'm just writing it here. Rho 1 R upon 3 epsilon naught into 4. For 2, it will be 1, 2, 3, 4, 5. So it will be K Q by 5R square. Okay. So Q dash I should write. So it will be 1 upon 4 pi epsilon naught Q dash 25 R square. Similarly, R multiply with this, and we can divide it. Divide by 3, multiply by 3. So it will be rho 2 is R upon 25, and we have a 3 also, right? So radius is 2r. Okay, so I have to, I need a 4 also. right? 8 also, so 8 into 8. Okay, because what I need is we need 4 by 3 pi 2r cube I need. So 8 also we need. So above there will be 8, right? Now it is fine. So rho 1 r upon 3 epsilon naught to 4. Okay, so we will have r will get cancelled. 3 epsilon naught cancel. So we will have, now look, if this is positive, it will be repelling this point. So it must be attractive, then only it will be. Yes. So this charge must be negative. In the first case, look, in the first case, it the both must be positive because this will repel this point and this will also repel this point. Okay. But in this case, if this is repelling, this must be attracting. Okay. So it will be minus. So rho 1 by rho 2 will be minus 32 by 25. So both are correct. B and D. Okay. So we'll consider this question as a moderate one. It's a nice question because you will forget this point and you will miss this. Right. Okay, perfect. So this video is already going a bit lengthy. Let's do another question. Okay. What we have here, a cubical region of side A has its center at origin. Okay, so here it encloses 3 points, minus q at here, plus 3q at 0, 0, and minus q at here. Okay, perfect. Choose the correct option. So flux must be asking. So though only, okay, we have only 2 points. Let me write other two. So see the plane, it will be y equals to minus a by 2. C point will be net flux through the entire region. So net flux through the entire region, it is saying q upon epsilon naught. I think it's correct. Maybe, I don't know. Let's go. The net electric flux through plane, net flux through plane z equals to plus a by 2 is equal to net flux through plane x equals to plus a by 2. X equals to plus a by 2, right? So okay, now let's start. So C option is correct, right? So net flux will be q upon epsilon because 3q minus q minus q. So from the whole cuboid, it will be cube, it will be q upon epsilon, right? Now let's move on to first A. The net flux from crossing the plane x equal to a by 2 and minus a by 2 will be equal. So yes, they will be equal. Why? Look, let me tell you first, this plane is x equals to a by 2. The plane just behind it. Okay, so this one. So this plane is x equals to minus a by 2. Okay. Now the above plane, this this plane is x equals to plus z by 2, and this plane downward, this is x equals to minus z by 2. Okay. Okay, now this plane, you see this one, this is y equals to plus a by 2, and this one, this is y equals to minus a by 2, right? Okay, perfect. Now if you think, look, this minus q is below this plane z by 2, x equal to z by 2 plane, and just below this. So look, the plane x equals to plus z by 2 and x equals to plus minus z by 2. They are equivalent planes. Okay, equivalent. So flux through them will be same. Flux through them will be flux through them will be same. Okay. Similarly, y equal to plus a by 2 and y equals to minus a by 2. Again, they are equivalent. So the flux through them will be same. Okay. It may be different. So I say it has a flux phi 1, it has flux phi 2. And similarly, if I say this was what? Yes, and next we have x equals to a by 2. Okay, so a by 2, a by 2. I'm sorry, a by 2, a by 2. They are all a by 2. Right? So this is a, not z, a, a. Okay, so these plane are all. Now the next we have x equal to plus a by 2 and x equals to minus a by 2. Again, it is also equivalent, and flux will be phi 3. Right? Right? Now look this plane. This one, x equals to a by 2, and okay, so this was z, sorry, my fault. So look, this plane, yes, which one, z equals to a by 2 and x equal to a by 2, these two plane, right? For them the charges are exactly similar, like equivalent. The placement of charges is same. Let me show you. So this is our plane, this is our x equals to a by 2, this is z equals to a by 2, right? So this is, these were z, these were z. Sorry, this was z, right? Okay, so these were z. Let me rub them. I've written z by 2, x equal to z by 2, so this is completely nonsense. So these are z plane, okay, up above and below z plane. These are x plane and these are y plane, okay, on the y axis. Now look, for this z equals to a by 2, okay, so these plane, okay, above. Now the charge is placed like that. This is the center, there 3q. Now on the left side of it at a by 4, okay, so this is a by 2 and this is a by 4, so there is minus q, and here this is again a by 2, the charge is minus q, my at minus a by 4 it is here, right. Similarly, for this plane, now look at this plane, right, this plane, the charge it here, right. So I have to make this plane like this. I have to make this plane a bit like this, right. This is not a y, I have made y. So you are getting me, right? You see this plane. So how will I make? uh, let me make here. Okay, so this plane, you see this plane, right? Now this charge is placed here. Okay, so how much it is at distance? So this is our x-axis. It's like this. This is like this. Okay. Now this is this plane is cutting this x-axis at x equals to minus a by 2. Okay. Now the charge is placed. This 3q is at the center, and this is here, and this is here. So this distance is again what? It will be, yes, right. Like these are on the y-axis, right? So this is on the y-axis. So these distances, this distances will be a by 2, right? So this distance will be a by 2. Similarly, this distance is what? This is on the y-axis, so this distance will be a by 2. Similarly, this distance will be a by 2. So like, look, the front plane, top, bottom, and the plane behind, which is x a by 2, x minus a by 2, z a by 2, and z minus a by 2. These all are similar planes. These are similarly placed according to the charge. So Q1 will be equals to Q3. Flux 1 due to x and A2 will be equals to flux due to z planes. Okay, so if we check, so this is a these are symmetrical. Okay, these four planes are symmetrical, but y planes are not symmetrical with them, so it will be different, right? So look, net flux crossing through a and minus a by 2 are equal. This is correct. Net flux through y a by 2 is more than y minus a by 2. This is wrong. It is same. Okay. So from y plane they are same because they are placed like symmetrically. Okay, symmetrically placed. Net flux, this was correct. Now net flux through z a by 2 is equals to net flux through a by 2. This is also correct. Okay. So if you study this, you can make a, you know, a model at your home, and then you can study this. You will get that these four planes, top, bottom, front, and back one, these are all symmetrical placed, but Y plane are symmetrically with themselves, but not with X and Z. Okay, so it's a bit complicated, but it's an easy question, right? So the video is already above 1.5 hours. We can still go. Okay, let's solve them. Okay, next four questions are extremely easy. So let's move on to 21. Okay, so we have our 21st question. So this is pretty easy. This is based on number of field lines per unit volume. So field lines density is more, then charge will be. So here there are more field lines compared to this. So Q1 must be greater than Q2. So this is wrong, B option. Now at a finite distance to the left of a, electric field is 0. Now look, so this is Q1, this is Q2, and they are opposite charge, right? Are they? Yes, they are opposite charge. How I know? Electric field from Q1 is going out and it is ending up in Q2. Okay, so from Q1 it is going out, it must be positive, and these field lines ending at Q2, it must be negative, right? And we know Q1, magnitude of Q1 is more than magnitude of Q2. Okay, so if I take a point P here, now due to Q1, electric field will be E Q1 here, and due to Q2, it will be here. But we know electric field due to Q1 will be more than electric field due to Q2 because this point is near to that, and even Q1 is more also. So it is always going to be more. So here there cannot be a point where electric field is zero. So electric field can't be zero here. Okay. Now here if I consider electric field due to Q1 will be here and electric field due to Q2 will also be here. So also there won't be any point you will get where electric field is zero. Now here you will definitely get why the Q due to electric field due to Q1 will be here and due to Q2 will be here. Now as Q2 is less than Q1, it is fine, but the distance is less. So there will be a point where the electric field due to Q1 will be balanced by Q2. So on the right side of the Q2 is option correct. So at the finalization or left of Q1, this is wrong. Okay. So it's an easy. This is a basic CBSE class 12th question. You can solve it. Okay. Next, let's move on to our 22 question. Number 22. Okay, perfect. So we have a positively charged thin metallic ring of radius r is fixed in xy plane. So let's make an x uh, and y plane. Okay, so let's consider this as x, this as y. So z will be this, right? From the right hand thumb rule. Or we have a metallic ring. So this is our metallic ring. Okay, centered at origin. A negatively charged P is released from a point 0, 0, Z naught. So 0, 0, and Z naught. A negative charge minus Q. So due to ring, we know electric force will be in this direction, right? If you derive it, you will find it. Thus, this is cos theta, right? Remember, and we have to take the component in this direction, so it will come out to be E cos theta, right? Okay, perfect. So periodic for all. Okay, let's see. So electric field will be here. If this is here, then force will come out to be. So there will be a periodic motion. So A is correct. Simple harmonic motion for all Z satisfying 0 is greater. No, this must be Z. Okay, Z not. So no, no. Z must be less than, much less than 1. Then only it will be SHM. So Z not must be much less than R. Then only it will be SHM. So this B option is wrong. Okay, for all the values. No. Approximately simple SHM for, yes, this is correct. Such that P crosses O continues to move along. No, it will be doing periodic. A option is correct, so D must be wrong. So A and C. That is again a very easy question. Let's move on to 23rd question. Okay, perfect. We have again non-conducting solid sphere of radius r uniformly charged. The magnitude of electric field due to sphere. Okay, this is a 12th grade question, you know. From here at a distance r, we know electric field increases as this, and from then onward, it will be like this, r square. Okay, and it is continuous field, right? Because at this point, from this, you can find rho r upon 3 epsilon naught at this r, a point, right? So electric field due to a, due to this formula, and due to this formula, it will be kq by simply r square, right? So if you find them, both will be equal. So it is not discontinuous, it is completely continuous. Increases as r increases for r, will, right? Correct. Decreases as r increases for, no, this is wrong. Decreases as r increases for math, this is correct. So A and C will be the option. So this is a basic class 12th question, right? Now the last question, 24th. Okay, so this is an interesting question here. A metallic solid sphere we have is placed in a uniform uh, electric field, so it has no charge, right? Even if I have charge, there must not be an electric field inside. So second and third will be wrong. Okay. The first will be wrong. Why? Look, if it is a metallic sphere and we have an electric field like this, then what will happen? That negative charge will come here, right? And positive charge will distribute like this. Okay. And the density of negative will be more, but net charge will be same. So this is suppose minus q, this will be plus q. Okay. Now, if electric field will come, this will come directly like this, but other electric field must come perpendicular to the surface, right? And they leave how? Perpendicular to the surface. So they must leave like this, right? So if it is coming like this, so they must leave like this, okay, right? And inside there must not be an electric field. So one is wrong because it is coming at an angle, right? But electric field must be perpendicular to the conductor, right? So 4 will be correct. This is wrong. So D option is correct, right? So we have discussed quite easy questions today. Okay, like I'm 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 taking these question topic wise, so in a flow we are discussing. In the next video, we will be discussing further question from this same topic, electric field and Gauss law and their application. Okay, so let's finish today's lecture. Thank you.